Hey class, this is an extremely important assignment getting us ready for Chapter 8. If you don't have time for anything else in pre-calc tonight, do this. This is important. It will set you up for Chapter 8, which is a tough chapter. And by doing this, it's going to take the edge off of it substantially. So I'm asking you to do a lot of calculations. It's going to practice Chapter 7 as well. So you've heard the expression, think outside the box. Well, in chapters 7.3 and 7.4, we've been thinking in the circle. We've been going around the unit circle, and now I want us to think outside the circle and look at trigonometry off the circle. And so what I've got for you is inputs and outputs. And I want you to calculate all the outputs. I want exact answers and decimal answers. And so I'm just going to grab a random one to show you and illustrate what you're going to be doing. So as an illustration, I'll just grab this one as a random input. And this is sine, so I'm going to calculate sine of 4 pi thirds. Now, I want you to come up with the exact answer without your calculator. And you may need to draw a picture. I'm going to erase this picture later. But here is pi, which is 3 pi thirds. So I know I don't have my picture for 4 pi thirds yet. So I'm going to extend that just a little bit more to 4 pi thirds. And now I can actually visualize, there's my reference angle. And it's the difference between 3 pi thirds and 4 pi thirds. So that is 1 pi third. Hey, wait, 1 pi third is the same as 60 degrees. So this problem will have the same answer as 60 degrees. And I've memorized 60 degrees, and I hope you have too. Except we're going to have to make a choice between positive or negative. So sine of 60 is the square root of 3 over 2, and we're in quadrant 3. So sine is a smart trig class. Sine down in quadrant 3, tangent's positive, but sine isn't. So I'm picking the negative answer. So when I come over here and plug in the answer, the exact output, 4 pi thirds is input. The exact output is negative square root of 3 over 2. Next, I want you to get a decimal answer for that. And that's easy. We can just type that in. I'm going to go to the home screen and I'll clear that. And I just remember that it's negative. So I'm going to do a square root of 3, get outside of the square root, divide by 2. Now, it's an irrational decimal that goes on forever and ever and never repeats, but I'm just going to round this to 0.87 for my decimal round off. So I'm going to do 0.87, and I have to remember it's negative. Now, that makes an ordered pair. I have an exact answer pair and a round off. So the pair would be 4 pi thirds and negative 0.87. Now I'm going to ask you to graph that point on the XY system. Actually, it's not X and Y. This is theta, my input axis, and this is Y, the output axis. So it's not like Y on the triangle now, okay? That Y is just up. And so I've got theta input, Y output, and I'm going to graph this point, 4 pi thirds. So if we look on the axis, I am seeing, here's 4 pi thirds right here. There's my X value, and I'm going negative. Here's negative 1. It's hard to read because of the grid system here. It's cut off all the negatives. But negative 1 is down here, and negative 0.75 is here. Now I'm not going to be able to do an exact graph here, but it's about 0.9, so it's really, really far down here, and I made a dot. Okay? That's what I'm asking you to do. And you're going to make many dots. I think there's like 16 or 17. So you're going to have a picture with 16 or 17 dots on it. That's all you need to do. And it's going to make you practice reference angles and exact answers. And then, of course, it's going to help you visualize on a different kind of coordinate graphing system here. Okay, last thing. I want you to expand or deepen your grasp of fractions. And so what I've done here is created the x-axis. And I want you to see the x-axis, but it's not x now. It's theta. So I want you to understand theta in a slightly different way. We're going to write theta as radians, and all these radians are fractions of a circle. So the coordinate system here, the way this is broken up so that you can read it here, I have pi sixths as a grid mark. And so I'm going to write that as 1 pi over 6. It's a little bit too thick for what I need here. Okay, now the next one, each grid is marking by pi 6. So this is 2 pi over 6. And this is 3 pi over 6. 4 pi over 6. 5 pi over 6. 6 pi over 6. 7 pi over 6. You see how this is going here, right? 8 pi over 6. And then you can see how I just finished off the rest of these. Now, what is 2 over 6? Well, 2 over 6 is pi thirds. That's just reduced. So on the axis here, I'm seeing pi thirds. What is 3 over 6? 3 over 6 just reduces to pi halves. So I can write it as pi halves or 3 pi sixths. What is 4 over 6? Well, 4 over 6 reduces to 2/3 pi. And what is 6 over 6? Well, 6 over 6 reduces just to 1 pi. And 8 over 6, 8 over 6 reduces, if I divide by 2, to 4/3 pi. Now, for some people that aren't great at fractions, it really helps to count these fractions because you're just counting by 1, 2, 3, 4, 5, 6, 7 pi 6, 8, 9, 10, 11, 12 pi 6. And we're just counting by pi 6. So if you're not good with fractions, that may help you. Some people look at the counting by sixths and see it's really elegant. Everything is in order. So you can make this grid system by sixths of pi. However, we can also count by thirds of pi. So here we could have 1, oops, that's way too thick. We could have 1 pi thirds. Now, then we jump to 2 pi thirds, and we jump, because these are 6, so I'm going to jump in pi thirds, and then we're going to have 3 pi thirds. And then we jump 2, and then we're over at 4 pi thirds. And then we jump 2, and then we're at 5 pi thirds. And then we jump 2, and now we're over at 6 pi thirds. Now 6 over 3 equals 2 pi. And 3 over 3 equals 1 pi. So if I count on this second line, I'm counting by thirds of pi. And I can scale my system. Now when we get into chapter 8, I just wanted you to have a better sense of graphing the x-axis by different kinds of fractions. And in chapter 8, most of the time we're not going to graph with 6 and thirds. We're going to graph with fourths. And I couldn't really put fourths on here very well. So the grid bars are based on 1/6 of pi. And here is a dot which correlates to 1/4 of pi. So this would be a grid of pi over 4. So right here in this region is kind of a grid line, and I've come over 1 pi fourth. And then, so notice the space here, it happens to be 1.5 pi sixths. 1.5 pi sixths is the same as 1 pi fourth. And then if I go 1.5 again, I'm right here, 2 pi fourths. If I go 1.5 again, I'm right here at 3 pi fourths. And if I go 1.5 again, I'm here at 4 pi fourths. Now, what is 4 pi fourths? That's 1 pi. And you can see that we can count this whole thing and scale it by pi fourths. So the pi fourths increments are on the dots. Every dot correlates to, well, not every dot, but every dot plus the nice values of pi fourths. And then I'm going to have another one here, which is 6 pi fourths. And then go 1.5 again over to here, and that's 7 pi fourths. And then go 1.5 again, and I'm at 8 pi fourths. Now, what is 8 over 4? Well, that's 2 pi. What is 6 over 4? That reduces to 3 over 2, so that's my 3/2 pi. So this might help you just in the future to visualize the x-axis. So in the future, I won't have a grid that's gridded out by sixths or thirds. Most of the time, we will be gridding by fourths of pi. But that is kind of a side note. That's a tangent. No pun intended there. That is a secondary subject. The main subject is for you to come back here and fill out all of these dots, all of these exact answers, and get all these decimal answers, and then plot points. That is your big job tonight, plot points. So I hope that gave you a little bit of insight, and study hard on this, a very important assignment.